Hello. Hello.
Yeah, it's clear.
Is it clear for you all?
Yeah, it is clear from my side. Students, is it clear for from your end? Please respond.
I think all are muted.
Yeah.
Okay, not an issue. Let us start the class so that we should not wait. Okay.
Yeah, students, please say that is it okay? Our audio is okay?
Yes, sir, everything is okay.
Okay, fine. That's fine. Thank you. Now you
Okay.
can start the class.
Okay, right. Thank you. Thank you. Good evening, guys. So, previous week I thought that I have to discuss with the problems, but because of some busy schedule, I went out of the campus, so I can't prepare that material. Definitely, the next week I am going to solve the problems. I am going to see the problems. But yesterday, when I am in Andhra in one conference, so one of our ADG has told me something about the next JRF and SRF exams. So I am sharing the same points with you friends also. So the next papers from JRF and SRF will be in applied aspects, not based on the subjects. So you can see the 2019 paper and also present 2000 previous back 20 paper. They are all applied aspects, specifically in irrigation concept, not on other concepts. I am specified on only on irrigation concept. So that's why I want to discuss with you some information which are applied aspects, not like that textbooks or something like that. So you have to think the problems or some questions based on the knowledge what you have understood in the topics, not based on the subject what you have read. Only on how best you can understand this topic, that can be helpful for you to solve that questions, specifically in irrigation, not on other aspects, because when it comes to the nutrient management, it is very specific. For example, what is the amount of nitrogen content in urea? You can say specifically 46%, but not like in irrigation, because what is the infiltration percentage in case of sandy soils, or what is the infiltration rate in case of black soils? It is highly difficult to say the specific now numerical. For example, in case of sandy soils, it may up to infiltration rate is 20 to 25 centimeter per hour. The option may be 22 or 23. You can't judge which is the specific option. So now I'm going to deal with such that topics, so that some problems what you are having may be solved. Definitely in the next week I'm going to say the problems related to irrigation. What are the irrigation calculations? Okay, right. So let me start. What are the factors affecting irrigation needs? Here the questions may be factors affecting irrigation need. The question like that. First, you can see that the crop water need is defined as the depth of amount water needed to meet the water loss through evapotranspiration. So questions may be, what is the definition may be the question. That means the term used to define as the depth of water needed to meet the water loss through evaporation, transpiration, both A and B, like that will be there. So the crop water need, that is ET, you have to know. Then irrigation need is different from the crop water need. It refers to irrigation need refers to the part of water requirement which is supplied additionally as external input. So the definition will be given and the question will be like this. So crop water need will be also there in the option, irrigation need will be also there. So you have to judge which is the best answer. So which is the suitable and correct answer. Then what is the water requirement? The total quantity of water required by a crop for successful completion of its life cycle. So questions may be, the JRF question will be like this. The total quantity of water required by a crop for higher yields, the total quantity of water required by a crop uh, for successful completion of its life cycle, both A and B, then all of these. The answer is both A and B, because yield is also the main concern and also its completion of its life cycle. For example, you may heard that limiting law of any nutrient which is any one element which is limiting the plant cannot be complete its life cycle. That is the nutrient related question. But when it comes to the water requirement, it is the total quantity of water required by a crop for successful completion of its life cycle. Here you may confuse about with the nutrient requirement and water requirement. That is limiting factor. Here it is water requirement factor. Okay, right. Then consumptive use. The water demand in the form of either soil evaporation and crop transpiration, together called as evapotranspiration, and metabolic needs, that is CU, it includes all the activities, all the water required for different activities. Then comes to the very important aspect is, what are the factors affecting water need? The factors contributing for irrigation needs of the crop can be categorized like soil factors like color, texture, structure, surface configuration. Here you have to note down this surface configuration. The question will be like this: the factors contributing for irrigation needs. The soil factor contributing for irrigation need is for options color, texture, surface configuration, all of these. The answer is surface configuration. Another question: the factor contributing for irrigation need of a crop can be categorized. The factors contributing for irrigation need is the soil factor contributing for irrigation need is surface configuration, subsurface configuration, both A and B, none of this. But here you should not select the subsurface configuration, because the subsurface configuration will not at all related to water needs. That means here the surface configuration is very important, but subsurface hard pan is very important when comes to the factors affecting water need. That means the surface configuration is the highlighting point to know the factors water needs. Then what are the agronomic factors? May you know that tillage, method of establishment, plant population, interculture, nutrient, weed, and other practices which are responsible. I will not go because it is like a theory class. If I go in depth, so I will go in surface. That means for questions whichever may be asked in the JRF or SRF questions, so I am concentrating on that factors. Okay, right. Then plant factors: variety, duration, growth stage, canopy structure. The question will be like this: the plant factor which is responsible for the crop water need. Option A variety, option B growth stage, option C canopy structure, option D all of this. Here all of these will be taken place. But when comes to the you can expect another one question like here it is there: variety of the same crop differ in duration. So option is like this: the plant factors which is responsible for the water need is duration of the crop, rooting pattern of the crop, both A and B, and none of this. So here we have to select both A and B, because here duration and also the rooting pattern. Here you have to concentrate on rooting pattern. What is the ratio that above plant canopy and below plant canopy is always it will be similar. That is 1:1 ratio, or in some crops it is 1:2.5, or in some crops it is 1:0.5. That means the above canopy it may be more, but the roots will be less. In some crops it will be in a similar way. That means 1:1 ratio it will be there. Okay, right. Then what are the weather factors which are affecting the crop water need? Various the weather elements like sunshine, soil and air temperature, humidity, wind, length of the day, rainfall, fog, all these factors are responsible for the irrigation needs. So here that when it comes to the temperature, humidity, wind speed, sunshine, etc., crop water need depends upon the if the temperature is high, then the evapotranspiration from the soil will be higher, then water requirement will be higher. When there is a temperature, cool temperature, then the amount of water required is very less, because the amount of water that is transpired by the surface is very less. When it comes to the humidity, when there is low humidity, then crop water requirement is higher. When there is high humidity, the crop water requirement is lower. Similarly, the wind speed and sunshine. The formula is very important. That is ET crop is equal to ET naught into Kc. The Kc is crop coefficient values. ET naught is that is the crop evapotranspiration data. ET crop we have to calculate. Here you can expect one problem. That means the question will be like this: the crop calculate the crop evapotranspiration. The given details are evapotranspiration, pan evapotranspiration or evapotranspiration data is at, for example, 12.94 and the Kc value is 1.96. Here you have to note down this formula. The ET crop is equal to ET naught into Kc value. Kc will be specific, that is crop coefficient value. That ET naught is the pan, that is crop evapotranspiration, that is evapotranspiration. We have to calculate ET crop. That means the problem, they will give the evapotranspiration data and Kc value, that is crop coefficient value. We have to calculate the ET crop. Okay, then here you can see the reference crop evapotranspiration ET naught, which are the different methods. Using pan evaporation, we can calculate ET naught here EPAN into Kp values. Okay, then type of class evaporation, it will be not required. Only thing is class A evaporation pan and sunken Colorado pan. What is the K pan value is very important here. What is the K pan value of class A evaporation pan and what is the K pan value of sunken Colorado pan? Here you have to concentrate only on these parameters, not on this water depth in a pan or water depth. They will not ask this type of question. Only the required parameter is K pan value of class A evaporation pan is 0.75 and K pan value of sunken Colorado pan is 0.80. It is very specific. And the another one parameter you have to concentrate here is equal to the total EPAN is 6 mm per day and total EPAN is 5 mm per day. Okay. The next one is Thornthwaite method. The Thornthwaite method, you have to specifically concentrate on the year in which they have given. In so many JRF question papers, they have asked the year itself. In which year the Thornthwaite method has been established, that is 1948. You can clearly have some knowledge that after independence 1 year itself we have got this Thornthwaite method. So the Thornthwaite method is given in 1948. This year is very specific. You should not remember almost all the formulas when they have given, but some formulas are there where you have to remember these years. That is the Thornthwaite method, that is at 1948. And then in Blaney-Criddle method, it is 1950. This is also the expected question. In which year the Blaney-Criddle method has been established? That is in 1950. After 2 years of Thornthwaite method, they have established this Blaney-Criddle method. Here you can see here there is some calculation how to calculate this Blaney-Criddle method or Thornthwaite method. It is not needed for you. It is of up to that SRF questions. It will not be given for JRF papers. Okay. Then what is the difference between Kc and Kp value? It is not required for you. Only thing you have to remember that Kc value is the crop coefficient value. In order to calculate the ET crop, you have to concentrate ET naught into Kc value. That means they will be given the reference crop evapotranspiration data and the Kc value, that is crop coefficient values. You have to multiply. It will give the evapotranspiration of the crop. Okay. Then these are all the some Kc values. Here you have to in some papers in SRF questions, they will ask the Kc value at mid-season stage and also the crop development stage. For example, only you have to it is very difficult to remember almost all the values. That mainly we have to remember only for maize, that is 0.80 and 1.15, and another crop is soybean. These two crops where they repeatedly asking the Kc values at crop development stage and mid-season stage. You have to concentrate only on that is maize 0.80 and 1.15 and also the soybean 0.75 and 1.10. These are all the applied aspects which will not be in some textbooks. Please note down these points. That is for maize at crop development stage is 0.80 and mid-season stage is 1.15. When it comes to the soybean, it is 0.75 and 1.10. These two crops you have to be remember and you have to be pakka. You have to know the values for these two crops. Other crops are also important, but specifically they may ask these two crops and also some other crops, but you have to know these two crops specifically. Okay. Then how to determine the crop water need for tomato using the following data. This is SRF question. You need not to worry. Okay. Any SRF papers are here? Can I know any SRF preparing people or only JRF? Hello?
Only JRF.
Only JRF. Okay, right.
No, sir. I am applied for ASRB Net Agronomy.
Okay, right. Okay, then you have to note down these points also. Okay, definitely. I will share all
Okay.
these things. No, need not to worry. But
Okay.
specifically, you have to know some crops which are expected questions in SRF also, or sorry, in ASRB also, right? Okay. Shall I continue? Okay, right. Then this is also not required. These are all the calculation part. It is required for SRF. Okay, right. Then soil plant water relationships and transpiration and evapotranspiration. Here you have to concentrate on adhesion, cohesion, capillarity. In every textbooks it will be there. I will not say much more on this. Only thing, adhesion refers to the concept of tight bondage between soil particles and water molecules. You know everything. And the force with which water adhered to soil lies between 31 to 10,000 atmosphere. This sentence must be highlighted and you have to note down this force. The adhesion force, the force with which water adhered to the soil by lies between 31 to 10,000 atmosphere, because you may confuse with these values. That is capillarity value will be some difference is there, adhesion value, cohesion value, and gravitational water, capillary water. It will be some differences. So for adhesion, 31 to 10,000 atmosphere. For cohesion, 0.33 to 30 atmosphere. When comes to the capillarity, that is the water held by cohesive force between 15 to 30 atmospheres. That means here, what do you mean by capillarity? It is a phenomena in which a liquid is attracted by soil particles and rises due to surface tension. Here, two types of capillarity are there. Two types of capillary pores are there: micropores and macropores. They will ask that non-capillary pores are macropores. It is a JRF question. Macropores are also called as capillary pores, non-capillary pores, both A and B, and none of these. But here, macropores are non-capillary pores and micropores are capillary pores, right? Then density and porosity. Density, you know, that only thing is porosity. The pore space of a soil is that portion that occupied by air and water. The soil particles are tend to be close, as in sand. The total porosity is low. This is the JRF question. The porosity is low in case of sandy soil, silty soil, clay soil, none of these. The expected question is the soil particle. The reason may be this: the soil particles are tend to be close in sand. The total porosity is low. But the question is, the total porosity is less in which type of soils? So the sandy soils having lesser porosity, right? Then aggregates as in medium and okay, this is not required. Then you have to know the bulk density formula and particle density. You know that it need not to be explained. Then volume wetness. What do you mean by volume wetness? It is the volume of water divided by volume of soil. That is, here you can expect one problem. Volume wetness refers to the volumetric share of water in total volume of soil. For example, the volume of water, they will not give the question like this: volume, what is the value of volume of water or volume of soil? They will give in liters. You have to convert. That means per acre basis they will give some water, what is the amount of volume. Then for example, what is the sorry, not an example, what is the amount of water present in that field and what is the amount you have given. That means some efficiency will be there. That type of problems will be solved in the next class. That is, but you have to know this concept. What is this concept? Volume wetness concept. That is nothing but it is the volume of water divided by volume of soil, so that it will be easily understood in the next while solving the problems. You will not get confused what is volume wetness or some other topics. Then what do you mean by mass wetness? This term you have to note down. This is very important. It is the percentage weight of moisture in a given weight of soil. That is the weight of moisture divided by weight of soil sample. That is the mass wetness. The formula is weight of moisture divided by weight of soil sample. That means here what is the concept you have to understood is the difference between the volume wetness and mass wetness. Now it is looking easy for you, but when solving the problems it will be difficult. So understand the concept now itself. It is the percentage weight of moisture in a given weight of soil. Here it is the weight of soil sample, here the volume of soil sample. So you have to understood, when comes to the mass, here weight will becomes, when comes to the volume, here volume will comes. Okay, then hygroscopic water, capillary water, gravitational water, you know very well. The very important concept is what is the force which holds the soil particles in hygroscopic water. That is, what is the force? Water held tightly to the surface of the soil particle by adsorption forces. It is the JRF question. The force with which water is held by the soil is adsorptive forces. When comes to the capillary force, what is the force? Here water held by relatively at lower force, that is 0.33 to 30 atmosphere as a continuous film. When comes to the gravitational force, it is the force responsible is gravity. But in case of hygroscopic water, you have to concentrate on what is the force with which water is held is adsorptive forces, right? Then when comes to the capillary water, you have to know that how much atmosphere, 0.33 to 30 atmosphere. You should not get confused with this capillary water and capillarity, right? Capillarity is different and capillary water is different. Okay, then gravitational water, that is water held very loosely, less than 0.33 atmosphere, that moves freely in response to gravity and drains out of the soil. That question, now applied aspect of the question is, can we get gravitational water for irrigation purpose? Option A yes, option B no, option B none of this. So that means I've given only a simple example. Gravitational water we can get, yes, gravitational water can be used for irrigation because this water will be available at some other depths, lower depth, because when the water enter into the soil, definitely it will move to the lower depth. When force of gravity will be there, it will pull the water downwards, it will be accommodate in some other places. That water can be taken by using that bore wells. So gravitational water can also be used for irrigation, but the question must be specific. Capillary water is only available to the plants. Availability, when comes to the availability for the plants, only water is capillary water. None other than hygroscopic water is not available. Capillary water, gravitational water is not available. Only the capillary water is available for the plants. But the question is, can gravitational water can be used for irrigating the plants? Here, you should not think that the notes will be there like this. That is, a capillary water is the only available water that is available for the plants. It is entirely different from the irrigation given to the plants. That means gravitational water can also be given only by using tube wells or bore wells. Okay, then when it comes to the soil moisture constants, here maximum water holding capacity, you know that, field capacity, you know, wilting point and temporary, you know that temporary wilting point, the range, permanent wilting point, and also the ultimate wilting point. I need not to explain. Then hygroscopic quotient, you know that. Here only thing, the gravimetric percentage, the soil moisture, that is mass wetness, volume wetness, linear measurement of water, it will be explained in next classes. That means while it is another, I may require another class for the explanation of this, so you can get acquaint knowledge for about on this. But you can note down these points, that is equal to 1 bar is equal to 0.9869 atmosphere, that is 1 atmosphere. Then 1 atmosphere is equal to 1036 centimeter of water, or 76.39 cm, 7639 cm of Hg, or 76.39 mm of Hg. But the values what you are using here, that is 1 atmosphere is equal to 1036 centimeter of water, and 1 bar is equal to 1023 centimeter of water is very important. These two values will be asked as recently and frequently, not recently, it is frequently asking in almost all the exams. 1 atmosphere is equal to 1036 centimeter of water, 1 bar is equal to 1023 centimeter of water. Okay, then soil moisture tension, you know that it is measured by tensiometer, and the PF value is given by Schofield. It is not an not required question. Then The important topics is relevance of different soil moisture expression. It is not at all required. Here, the average values of moisture percentage for different soil texture is indicated below. This is what you required now. That means in some ASRB questions, this question will be asked. What is the field capacity for silt loam? What is the field capacity for sandy loam? What is the field capacity? They may ask any type of soil texture. Only maximum they will ask only for field capacity. That means this you must be acquainted with knowledge. That means how to note down these values and you have to always remember these values. Okay. Then moisture equivalent, available soil moisture. How to calculate available soil moisture? Field capacity minus permanent wilting point divided by 100 into bulk density into depth of the soil. Okay. But the only thing is you have to know how to calculate this field capacity. They will not give the direct answer. It will be there in yeah, definitely it will be there for JRF also. Available soil moisture formula. Sometimes they will alter the formula. That means permanent wilting point minus field capacity they will give in that means in options. But in ASRB questions or in a JSRF question, they will give the problems related to this concept. Okay. Then very important topic is hysteresis. Please note down this. It is very important concept. Hysteresis refers to the study of desorption and absorption pattern in given soil. That means for various soils, absorption pattern and desorption pattern is different. For example, absorption in case of clay soil is entirely different from sandy soils, and it is entirely different from loamy soils. So hysteresis is very important concept that refers to the study of desorption and absorption concept in a given soil. Okay. Then percolation, seepage. Okay. The theory of water movement in soils is based on Darcy's law. You have to know the formula of the Darcy's law. Q is equal to KIA. Here they will ask in Darcy's law, K represents. This is the important and specific question they will ask. In Darcy's law, the K represents, it is hydraulic conductivity and the unit is centimeter per second. That unit is also important, and also the K representation. In Darcy's law, what is K represent? For example, in case of soil loss equation, what do you mean by RKLSCP? That is soil loss equation, universal soil loss equation. You note on that RKLSCP, what is the R represents. Similarly, here also in Darcy's law, what is K representation? That is here, that is hydraulic conductivity, centimeter per second. Then transpiration and energy, it is not at all required. Now comes the transpiration, stomatal transpiration, cuticular transpiration, lenticular transpiration. Three types of transpirations are there. Among them, which is the more amount of water transpired by which type of transpiration? Stomatal, cuticular, lenticular, all of this. Answer is stomatal transpiration, because 90 to 95% of the water transpired by through stomata only, not by other process. Then amount of water, 10% of the total transpiration, that is 5 to 10% is by cuticular transpiration. You should not confuse with this cuticular and lenticular transpiration. Okay, here you can see stomatal transpiration 90% followed by cuticular transpiration 10%, and lenticular transpiration is negligible. It will occurs only in lenticels, that too in case of some woody plants. It is not at all similar, but only thing you have to note down is 90% and 10%. The stomatal transpiration 90% and cuticular transpiration 10%. That is the thing you have to note down. That is the stomatal transpiration is 90% and cuticular transpiration is 10%, and the lenticular transpiration, the question will be like this. The lenticular transpiration occurs in woody stems. That is the one, the woody stems, the transpiration occurs in woody stems. Option A stomata, option B cuticular, option C lenticular, all of these. So some water may be lost by woody stems through lenticels. So you have to get that information. Okay, right. Then mechanism of stomatal transpiration, it is not at all required. It is some in-depth it is there. Mechanism of control of stomata is also not required. That is why stomata will open, why stomata will close. That is the concept, because of synthesis of starch. Some other concepts are there. It will be discussed in later chapters. That means because they are also the applied aspect, they will ask they are asking this type of questions in JRF also. I will take some time. That means I will take all these topics in depth in next classes. Okay, then all these energy concepts and other different concept I will be discussed in the next class. So I want to discuss with you now. Okay, what are other now? Hello.
Hello.
Hello. Right. Now for today class, I will stop for this concepts itself. Now pertaining to this concept, tomorrow next week I'm going to solve the problems. Then the next class, some other concepts will be dealt, and relating to that concepts in the next particular classes, I'm going to solve the problems. Okay, right? Hello.
Hello.
Yes, Sharma.
Sir, will you provide us this lecture notes?
Yes, definitely I will give. I will share in this WhatsApp. I am compiling all this. I'm not
Okay,
giving
sir.
because it is of like SRB notes. Okay, definitely I
Mhm.
will share you. I am highlighting some points so that it will be helpful for you. And
Yeah, sir.
notes given by already I have sent this for manual preparation. That means notes preparation. I think all the information it will be there in that notes. But some points when I am dealing with these concepts, you will know what are the different concepts rather than that notes. Okay, definitely I
Okay,
will
sir.
share.
Okay, thank you, sir.
Okay, right. Any doubts regarding to this class today? Because whatever the concepts I have explained you now, the problems related to these concepts will be next in the next week. I'm going to deal with these problems because you have to know the concepts now, so that in the next class you can get the information what are the problems related to how you have to analyze the available soil moisture, how you have to calculate the available soil moisture, how you have to calculate the porosity values in different concepts, and how you have to calculate some soil related properties. That will be dealt in next class. So if you are having any doubts in today's class, please ask me so that I can know and I will solve now itself. So next week, so while solving the problems, you have to get the information about this concept. So that's why I'm asking you.
Excuse me, sir.
Yes.
So please tell me about bulk density and particle density.
Okay,
I'm
right.
not clear about it.
Okay. Now you can see I'm sharing my screen. Wait. Here, the particle density, the bulk density can be easily altered by different practices. That means by using tillage practices or some application of some organic manures, we can change this bulk density, but we can't alter the particle density. Okay, the difference between the bulk density and particle density, it is there. So now I'm, wait. So in some textbooks, bulk density can alter can be questions will be like this: the bulk density can be altered or particle density can be altered. Only thing is the bulk density. Here you can see the particle density. It is the weight of unit volume of soil solids excluding pore space is particle density. Bulk density is the weight of unit volume of dry soil include both solid and pore space. That means here when the soil is dry, for example, you are having 100 grams of soil. In that, if the macropores will be there and also the micropores will be there, that means here both solid and pore space. That means the solid particles means that is the macropores and micropores. How much amount it is having, that is the weight of unit volume of dry soil. Here we are concentrating on dry soil, which includes both solid and pore spaces. But in case of particle density, here we are concentrating on unit volume of soil solids excluding the pore space. Here you can see the formula: bulk density is equal to weight of soil divided by volume of soil. The particle density is equal to weight of soil divided by volume of solid. That is nothing but how much amount of pore spaces are there. Okay, definitely it will be, I will clearly explain when solving the problems also, because so many problems will
Sir,
be there.
So solid particles include both the pores.
Where? Both, yes. Solid
Both the
particles
pores.
includes, yes, both solid, yes.
And so what about these pore spaces?
It includes both solid and pore space in case of bulk density.
Okay.
In case of
So,
particle density, we are excluding the pore space.
okay.
Here we are including only the soil solids, volume of soil solids. Here we are not taking count of pore space in case of particle density. Okay, when it comes to the bulk density, we are including both solid and pore space. Right?
Okay, sir. Okay.
Okay.
Sir, tell me about field capacity also in a general way.
Okay. So one concept is, for example, I will say in a general line. Okay. For example, you are having a field. If you irrigate the plot not before one day. For example, you go on Monday. Monday you are going to irrigate some, for example, sandy loam soil at 9 o'clock. Okay. After 24 to 36 hours, the water will drains out. Excess water will drains out by action of gravity. The remained water will be there in both macropores and micropores. The water filled within both macropores and micropores. That situation is called as field capacity. Understood? After almost all the gravity power is pulled on the amount excess water, the remaining water, which is established after 24 to 48 hours in some different soils, is called as field capacity. Okay?
Okay, sir. Thank you.
Okay. Right. Any other clarifications you needed, guys, so that I can discuss with you? Okay, right. Thank you. Bye.
Thank you, sir.